Hello guys, welcome back to the channel. Today we'll be doing the national sprint round for Mathcounts 2000 problems 11 through 15. So starting off with question 11, palindromic primes are numbers that are prime which read the same backwards and forwards. For example, 11 is a palindromic prime. So what is the sum of all palindromic primes between 100 and 200? So if it's between 100 and 200, then that means the hundreds digits must be 1, and because it has to read the same forward and backwards, the units digits must be 1 as well. So the middle number can just be 1 through 9. So 111, 121, 131, 141, 151, 161, 171, 181, and 191. Okay, there are 9 possible palindromes. But how many of these are prime? So first of all, 111, is that prime? That is not prime, because 111 is divisible by 3, because 1 plus 1 plus 1 is equal to 3, and we divide that by 3. It is divisible. So 111 is not prime. And 121 also is not prime, because it's 11 squared. What about 131? Is 131 prime? We can leave that for now, and then we can check it later. Let's first eliminate the palindromes that we know are not prime. So 141, that's at the digital sum is equal to 6, so that is not prime. 151, we're not really sure right now. 161, we're not really sure right now. 171, that adds up to 9, so that's not one of them. 181, not really sure. And 191, we're also not really sure. So for now, we eliminated 4 of them that obviously isn't prime. But now, let's see, is 131 prime? So first of all, these numbers cannot be divisible by 5. Well, 7. Is it divisible by 7? It isn't divisible by 7 either, because there's a rule. You can double the units digit, and then the rest of the number minus double the units digit. Is it divisible by 7? 13 minus 2 is 11, so that is not divisible by 7. What about 11? 121 is also divisible, so we know that it doesn't work as well. 13, there's a 13 divide that does not divide, because 13 times 10 is 130, so it can't. So 131 should be prime. Yeah, I just remembered. There's also 101. Don't forget that one. And 151, is that prime? It's not divisible by 3. Is it divisible by 7? 150. So we can multiply the last digit by 2 and then subtract it out. That's 13. That is not divisible by 7. But according to this rule, we can see that 161 should be divisible by 7. Because 1 times 2 is 2. 16 minus 2 is 14, and that's divisible by 7. So we're left with 101, 131, 151, 181, and 191. So yeah, you can double check, but I already double checked them. They're not composite. They're all prime, so we can add it all up. So we see here they all have 100. They're having 101. There's 1, 2, 3, 4, 5 numbers. So we multiply by 5. 505, and then plus a 30, plus a 50, that's 80, and then plus 80, that's 160, and 160 plus 90, 250, plus 250, that's going to be 755. So our answer should be 755. So yeah, also be sure when you're taking the test, be very, very careful. even after I solved the problem, you see in the explanation, I almost forgot about 101. So yeah, make sure you like double check, triple check if you have time. There's a tip for math counts. When I was doing like math counts, the first few questions are usually like pretty simple, very easy. So you can like quickly rush over them, and then you can still have time to check over, and then leave time for like the harder problems. That's pretty much what I did. So yeah. Okay, number 12. A fair six-sided number cube with the digits 1 through 6 on its faces is rolled 3 times. And then the positive difference between the values on the first 2 rows is equal to the value of the of the third row. What is the probability that at least 1 3 was rolled? Okay. The positive difference between the values on the first 2 rows is equal to the value of the third row. Okay, let's say the first row is 3. Okay, and then we can second row, and then a third. So if the first row is a 1, then is 3, then the second can be anything we want. It could be 1, then that could be 2. 3, if that's 2, then it could be 1, and then 3, 3, 0. That's not possible, so that does not work. And then 3, 4, 1. It's asking for the positive difference, so 4 times 3 is 4 minus 3 is equal to 1, so that works. And 3, 5, 2, and then 3, 6, 3. So all of these work. So what if the second number is 3? Let's see, so 3, if it's like 1, the positive difference is 2, 2, 3, 1, and then 3, 3, we already said it doesn't work. 4, 3, 1, 5, 3, 2, and then 6, 3, 3. Okay, and then finally, what if the third row is 3? So let's see, if the third row is 3, and then we have like 1 here, then it could be 4, 4, 1, and then 2, that's 5, 2, and then 3, 6, 6, 3, 3, we already see here, so we don't want to repeat it. And then what if it's 4, then it can be like 1, if it's 3, 5, that's 2, and then also, yeah, we can have like a 6. No, we can't have 6, 3, 3, but we can have like 3, 6, 3. That also works. So let me double check. How many? Why can't I scroll? Okay. How many possible results can we have? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do we have any repeats? I feel like we do. Can double check. I think this is the smallest I can go, so 5, 3, 2, 3, 4, 3, 6, 3. Yeah, there's a repeat 3, 6, 3 in here. So there should be just 14 possibilities. And then what's it asking us? It says, what's the probability that at least 1, 3 is rolled? So okay, and then it says the positive difference between the value of the first 2 rows is equal to the value of the third row. So how many conditions satisfy? If we see, there should be 30 conditions that satisfy it, so divide by 30, that's 7 over 15. So our answer should be 7 over 15 for this one. Originally I thought it was like something like 14 over 216, but it already states that the positive difference between the value in the first 2 rows is equal to the value of the third row. And for example, if you have like the third row is 6, then that's just not possible. because we can't have like a 0. And if it's like 5, there's only 2 possibilities. See, so for 4, there's like, I think 4 possibilities. Something 1, 5, 2, 6, and then times 2. So yeah, in total there's like 30 possibilities that satisfy the statement. So our answer should be 7/15. Okay, the next problem is the product of the 2-digit number and a 5 is equal to the product of the same 2-digit number with its digits reversed and 6. What is the sum of the digits of the number? So how do we do this? So we can express a 2-digit number as 10a plus b. We have to go back to like elementary school math. And the first digit is the tens digit is a, and the units digit is b. And the product of this and 5 is equal to the product of the same 2-digit number with its digits reversed. So just 10 times b plus a, and then that times 6. Okay, so we have 50a plus 5b is equal to 60b plus 6a, right? And then it's asking us, what is the sum of the digits of the number? So how do we do that? We can try to simplify this a little bit. That's going to be 44a is equal to 55b. If we if we subtract 6a from both sides and 5b from both sides, and then we can just divide by 11 both sides. So 4a is equal to 5b, and and we know that the digits should all be integers. So what do we think? It could be like 5 and 4. Is that the only way though? Yeah, I think so. So the sum of the digits of the number should be just equal to 9. And how do we get 5 and 4? Well, we know that a and b have to be both integers, so they should just be 5 and 4, because 4 times 5 is 20 and 5 times 4 is also 20. So yeah, so 5 plus 4 equals 9. And then like this one was pretty fast, and you have like time, you can like double check. So 54 times 5, is that equal to 45 times 6? That's just equal to 9 times 6 times 5, and that's 5 times 9 times 6. So yeah, they're equal. So our answer should be 9. Alright, our next problem is a box containing 5 balls numbered 1, 2, 3, 4, and 5. There's a box, yeah, and then 3 balls are drawn random without replacement. Okay, without replacement, that's a keyword. What is the probability that the median of the values of the 3 balls chosen is greater than 2? Okay, so they aren't chosen without replacement. They are chosen without replacement. So let's see. What is the probability that the median is 2? Okay, that there's only like a couple cases. 1, 2, 3, 1, 2, 4, and 1, 2, 5. Okay, so all their values should all just be have a median greater than 2, I think. Let me check. So if that's 2, 3, 4, yeah, that should be. And then like if it's anything like anything like that, but there's different like permutations for this, I think. So you can choose like 1, 2, and 3, but like you can also choose like 2, 1, and 3. That's also the same thing. And 3, 1, and 2. So there should be like 6 of them here, and also like 6 of them here, 6 of them here. So it should be 18, right? And then how many possibilities are there? So on the first draw, there should be 5, right? There's 5 possibilities you can draw. And then without replacement, right? So the second one, there's 4 possibilities. And the third one is just 3 left, so 3. So that's just 5 times 4 times 3, which is that's 20, 60, right? And then divide both sides by 6. That's just 3 over 10. So 3/10 possibility that the median is not greater than 2. So 7/10 probability that the chosen balls have a median that is greater than 2. So that's the answer for question number 14. Alright, ending the video with a fairly easy question. What is the number of centimeters in the perimeter of the rhombus shown? So, first of all, it gives us a very crucial information that it's a rhombus. It's a rhombus. Okay, what is a rhombus? A rhombus is a shape, quadrilateral that has 4 equal sides. So technically, a square is a rhombus, but a square is not. Rhombus is not a square because we don't know if all 4 angles of a rhombus are 90 degrees. So what can we do with this information? So we know that the height is 9, right? And if we draw like a perpendicular, then this is going to be 90 degrees. And we know that's 150, so this is just 60 degrees, right? And 60 degrees, and then we can just find this is 18 using like our trig ratios. And if you want to just like quickly prove it, it's pretty simple as well. So in a like equilateral triangle, it's 60 degrees, 60 degrees, and then 60 degrees. And then if you have like A, and if you like cut it, then this is just going to be like half A, and this is going to be 30 degrees. So yeah, in this case, it's just a little bit differently oriented, but I'm gonna get that each side is 18. So what can we do now? If we try to do this, then we don't really know what this little section is, but that's when we remember it says that it's a rhombus, so that each side is equal to 18. So if we want to find the perimeter, it's just 18 plus 18 plus 18 plus 18, or 18 times 4. That's just 18 times 4 is 20, times 4, that's 80, minus 8, so 72. So yeah, the number of centimeters in the perimeter should be 72 centimeters. So yeah, we finished problems 11 through 15. See you in the next video.